Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. Today our topic is cube roots of unity and their properties. First, the cube roots of unity. Let a number x be the cube root of unity. So we can write x as x is equal to 1 raised to power 1 by 3. Unity mean 1. So since x is a cube root of unity, so x is equal to 1 raised to power 1 by 3. Now we can take cube on both sides. When we take the cube on both sides, the left hand side is equal to x cube and the right hand side will be equal to 1. So it means x cube is equal to 1. When we shift left 1 to the left hand side of the equation, we have x cube minus 1 is equal to 0. This can be written as x cube minus 1 cube. 1 can be written as 1 cube. So now we can use the formula a cube minus b cube, which is equal to a minus b times a square plus ab plus b square. So by using this formula, x cube minus 1 cube can be written as x minus 1 times x square plus x plus 1 is equal to 0. So either x minus 1 is equal to 0 or x square plus x plus 1 is equal to 0. If x minus 1 is equal to 0, it means x is equal to 1. And we know that this is the standard form of the quadratic equation. To find root of this quadratic equation, we have to use the quadratic formula. And we know that the quadratic formula is x is equal to minus b plus minus square root of b square minus 4ac over 2a. And here a is equal to 1, b is equal to 1, and c is equal to 1. A is the coefficient of x square, b is the coefficient of x, and c is this constant value. By using the quadratic formula, we can write this as x is equal to minus 1 plus minus square root of 1 square minus 4 ac. A is 1, c is 1, divided by 2a. 2a, here a is 1. Now we can simplify this as square of 1 is, now we can write this as square of 1 is 1, and this 4, 1 into 1, this is minus 4. So now 1 minus 4 can be written as minus 3. So since iota square is equal to minus 1, so square root of iota, square root of minus 1 is equal to iota. So we can write this as in term of iota. So this is equal to, so we can write that as 3 cube root of unity r. First is 1, and the complex cube root of unity of minus 1 plus iota square root of 3 divided by 2, and minus 1 minus iota square root of 3 divided by 2. So where iota is square root of minus 1. So these are the cube roots of unity. Next, now recognize cube roots of unity as omega and omega square. The two complex cube roots of unity are minus 1 plus square root of minus 3 all divided by 2, and minus 1 minus square root of minus 3 divided by 2. If we take omega is equal to this first cube root of unity, then we have to take the second root as a omega square. And if we take this second root as omega, then we have to take this first cube root as a omega square. So we can take omega and omega square. If we take first as omega, then we have to take second root as a omega square. If we take the second root as a omega, then we have to take the first root as a omega square. So difference between these two roots is that in first root we have the positive sign between -1 and square root of -3. And this in the second root we have a negative sign between -1 and square root of -3. So we can take either first root as omega or omega square. If we take the first root as a omega, then we have to take the second root as a omega square. And if we take the second root as a omega, then we have to take the first root as a omega square. So now we are going to prove the properties of the cube roots of unity. First property, prove that each of the complex cube roots of unity is the square of the other. It means we have to prove that the complex cube roots, which are -1 plus square root of 3 divided by 2 and -1 minus square root of 3 divided by 2, are equal to. So we have to prove that if we take the square of first root, then we have the second root, and if we take the square of second root, this will be equal to square of first root. That's why we can write as first as omega and the second root as omega square, or if we take first as omega square, then we can take the second as omega square. These cube roots are the square of the other. Just you can take either of the root as a omega and the second as a omega square. So we have to prove that when we take the square of the first root, then we have the second root, and we take the square of second root, we have the first root. So just squaring, when we take square of 1 by 2, we have 1 by 4, and when we take the square of this, we have to use here the formula of a plus b whole square. So here a is -1 and b is equal to square root of -3. So a plus b whole square is equal to a square plus b square plus 2ab. So this is -1 square plus square root of -3 whole square plus 2 -1 times square root of -3. So now here again we have to use the formula a plus b whole square. So here a is equal to -1 and b is minus square root of -3. So we can write this as, so square of 1 by 2 is 1 by 4, and this is -1 square plus minus square root of -3 whole square plus 2. This is first value and this is second value. So now we can write this as, this is 1 by 4 and -1 square is 1, and square of square root of -3 is -3, and now this can be written as -2 square root of -3. Here we can write this as 1 by 4, and -1 square is +1, and here is -1. When we take the square of this minus, we have positive, and when we take the square of this root, we have square root of -3. When we take the square of square root of -3, we have -3. So here we have negative, and here we have, when we multiply these two negatives, we have positive. So we can write this as 2 square root of -3 whole divided by 4. So here's 1 plus -3, this is -3. It means 1 minus 3 is equal to -2. Minus this value is same as it is, -2 square root of -3 whole divided by 4. And here we have 1 plus -3. So we have plus -3. This means when we multiply this plus with this minus, we have -3. So -3 plus 1, we have -2, and here we have +2 square root of -3 divided by 2. Now we can take 2 as a common. So when we take 2 as a common, we have within bracket -1 minus square root of -3 whole divided by 4. And here again we can take 2 as a common. So we have -1 plus square root of -3 whole divided by 4. Now this 2 cancel with this 4, 2 once time 2 and 2 2 times 4. So we have here 2, and here this 2 cancel out with this 4, we have 1 by 2. So minus 1 minus square root of minus 3 divided by 2, and here is minus 1 plus square root of minus 3 divided by 2. So when we take the square of minus 1 plus square root of minus 3 divided by 2, we have minus 1 minus square root of minus 3 divided by 2. And when we take the square root of minus 1 minus square root of minus 3 divided by 2, we have minus 1 plus square root of minus 3 divided by 2. So if when we take the square of this positive root, we have this negative, and when we take the square of this negative root, we have this positive root. So if we take, so we can say that each of the complex cube root of unity is the square of the other. That is, if omega is this positive with this positive value minus 1 plus square root of minus 3 divided by 2, then omega square will be equal to minus 1 minus square root of minus 3 divided by 2. And if we take omega is equal to minus 1 minus square root of minus 3 divided by 2, then omega square will be equal to minus 1 plus minus square root of minus 3 divided by 2. So each complex cube root of unity is the square of the other. Next property, prove that the product of three cube roots of unity is 1. So three cube roots of unity are 1 minus 1 plus square root of minus 3 divided by 2, and minus 1 minus square root of minus 3 divided by 2. So when we take the product of these roots, we have in this form, where so when we multiply this with this one, we have minus 1 plus square root of minus 1 and divided by 2. And this is minus 1 minus square root of square root of minus 3. Sorry. The second property, prove that the product of three cube roots of unity is 1. Three cube roots of unity are 1, minus 1 plus square root of minus 3 divided by 2, and minus 1 minus square root of minus 3 divided by 2. When we take the product of these cube roots of unity, we have this form. When we multiply this with this one, this is equal to this. So here we have 1 minus 1 plus square root of minus 3, and here is minus 1 minus square root of minus 3. So we can use the formula a square minus b square. So this can be written as minus 1 square and minus square root of minus 3, and when we multiply this 2 with this 2, we have 4. Square of minus 1 is plus 1, and square of square root of minus 3 is minus 3. So when we multiply this minus with this one, we have plus 3. So 1 plus 3 divided by 4. So 4 divided by 4 is equal to 1. So we can say that 1, and if we take this omega and this omega square, so this is the product of these is equal to 1. So when omega and omega square mean omega cube is equal to 1. So you have to remember that the omega cube is equal to 1. So if we have the value of omega greater than 3, then we can write that value in term as a omega cube. So for example, if we have omega 4, then we have to we can write this as omega cube and omega. So omega cube is equal to 1, so we have omega. So each term of omega, each power of omega can be written as a omega or omega square. Next, fourth property, prove that the sum of all the cube roots of unity is 0. That is 1 plus omega square is equal to 0. And this property, you have to remember that we use this property when we solve the exercise question. So this is very important property. The the third property, that is omega cube is equal to 1, and this property 1 plus omega square is equal to 0. These are the most important properties of the complex cube roots of unity. Let's start the proof. The cube roots of unity are 1 minus 1 plus square root of minus 3 divided by 2, and minus 1 minus square root of minus 3 divided by 2. If we take omega is equal to minus 1 plus square root of minus 3 divided by 2, then it means omega square is equal to minus 1 minus square root of minus 3 divided by 2. The sum of all three cube roots of unity is equal to 1 plus omega square. So now we have to replace the values of these. Omega is equal to minus 1 plus square root of minus 3 divided by 2. So this is value of omega, and this is value of omega square. Now we can take 2 as a LCM. When we take 2 as a LCM, so here is 1. So 1 2 times 2. So we have to multiply 2 with this one. So here this 2 cancel out with this one. So we have 1. So when we multiply 1 this one, we have same as it is, and here this cancel out with this one, and we left with 1. And when we multiply this one with this, we have this term. Now you can see that here is 2, and this is minus 1, this is minus 1, this is minus 2. So we can cancel positive 2 with negative 2, and here is this plus square root of minus 3, and there is and here is minus square root of minus 3. So this cancel out with this one. So we left with 0 divided by 2. So 0 divided by 2 is equal to 0. So we can say that 1 plus omega square is equal to 0. So the sum of all the cube roots of unity is 0. Exercise 2.2, question number 1. Find the cube roots of minus 1, 8, minus 27, and 64. Let a number x be the cube root of minus 1. So we can write x is equal to minus raised to power 1 by 3. Now we have to take cube on both sides. So x cube is equal to minus 1. So now we can take this minus 1 to the left hand side of the equation. So we have x cube plus 1. So 1 can be written as 1 cube. So now we can use the formula a cube plus b cube, which is equal to a plus b a square minus ab plus b square. By using cube formula, we can write this expression as x plus 1 x square minus x plus 1 is equal to 0. So either x plus 1 is equal to 0 or x square minus x plus 1 is equal to 0. If x plus 1 is equal to 0, it means x is equal to minus 1. And x square minus x plus 1 is equal to 0. This is the quadratic equation, and we use the quadratic formula to find its roots. So here a is equal to 1, b is equal to minus 1, and c is equal to plus 1. We know that the quadratic formula is x is equal to minus b plus minus square root of b square minus 4ac all divided by 2a. Now b is equal to minus 1, so this minus and this minus will be positive, plus 1. Here is minus 1 square and minus 4a is 1, c is 1. So here this is typing mistake, you must write here minus. So minus 1 square will be positive and this will be equal to minus 4. So x is equal to 1 plus minus square root of 1 minus 4 divided by 2. So 1 minus 4 is equal to minus 3. So x is equal to 1 plus square root of minus 3 divided by 2. So we can write this with positive and negative sign. So x is equal to 1 plus square root of minus 3 divided by 2, or x is equal to 1 minus square root of minus 3 divided by 2. Now we can write these cube roots in form of cube roots of unity. So now if I multiply with minus, here I taking minus inside and outside, so that this minus cancel out with this one, so we have this term. So when we multiply minus 1, we have this minus 1 minus square root of minus 3 divided by 2, and another minus we have taken here. So this minus and this minus cancel out with each other, and we have this positive, or when we multiply minus with minus, we have plus. Again, when we multiply minus here, we have minus 1 plus square root of minus 3 divided by 2, and we have also taken minus here to balance these. So we know that if this term minus 1 plus square root of minus 3 divided by 2, so we take this as a omega, and the minus 1 minus square root of minus 3 divided by 2 as a omega square. So this is x is equal to minus omega square, and here x is equal to minus omega. So the required 3 cube roots of minus 1 are minus 1 minus omega and minus omega square. Part 2. Let a number x be a cube root of 8. So now x can be written as a cube root of 8, taking cube on both sides. So we can write this x cube is equal to 8, and now we have to shift this 8 to left hand side. So 2 can be written as 2 cube, 8 can be written as 2 cube, and now we can use the formula a minus b, a cube minus b cube. So a cube minus b cube is equal to a minus b times a square plus ab plus b square. So here a is x and b is 2. So by using cube formula, we can write this as a x minus 2x square plus 2x plus 2 is equal to 0. So either x minus 2 is equal to 0, or x square plus 2x plus 4 is equal to 0. So from here we have x is equal to 2, and here we have to use the quadratic formula to find the roots of this quadratic equation. So here a is equal to 1, b is equal to 2, and c is equal to plus 4. So we know that the quadratic formula is x is equal to minus b plus minus square root of b square minus 4ac divided by 2a. So here b is 2, and a is 1, c is 4. By replacing the values, we have this form. Now 4 minus 16 minus 12. So minus 12 can be written as 4 times 3, and 4 can be written as 2 square. So when so 2 can be taken outside the square root. So we have inside minus 3 x is equal to minus 2 plus minus 2 square root of minus 3 whole divided by 2. So now we can take 2 common from the, and we can also write this in form of iota, since square root of minus 1 is iota. So after writing in form of iota and taking 2 as a common, so first we write with the positive sign and second with the negative sign. So we know that this is the value of omega, and this is the value of omega square. So we can, so here is 2. So this whole expression is omega. So this is 2 and into omega, 2 omega, and this whole expression within bracket, this is omega square. So the 3 cube roots of 8 are 2 omega and 2 omega square. Part 3. Let a number x be the cube root of minus 27. So x is equal to minus 27 raised to power 1 by 3, taking cube on both sides. So x cube is equal to minus 27. When we shift minus 27 to the left hand side of the equation, we have x cube plus 27 is equal to 0. 27 can be written as 3 cube. So x cube minus 3 cube can be written as x plus 3x square minus 3x plus 3 square. 3 square is 9 is equal to 0. So now either x plus 3 is equal to 0 or x square minus 3x plus 9 is equal to 0. If x plus 3 is equal to 0, it means x is equal to minus 3, and x square minus 3x plus 9 is equal to 0 is the quadratic equation, and by using quadratic formula we can find the roots of this quadratic equation. We know that the quadratic formula is x is equal to minus b plus minus square root of b square minus 4ac over 2a. Now expression coefficient of x square is 1, so a is 1. Coefficient of x is minus 3, so b is minus 3, and the constant term is 9, so c is equal to 9. By replacing these values in quadratic formula we have this expression, and after simplification we have 3 plus minus square root of minus 27 divided by 2, and the 27 can be written as 9 multiplied by 3, and 9 can be written as 3 square. So 3 square within the bracket, we can take 3 outside the bracket, within the again x is equal to 3 plus square root of minus 27 divided by 2, and this 27 can be written as 9 multiplied by minus 3, that will be equal to minus 27. So 3 square 9 can be written as 3 square, and we take 3 outside the square root. So 3 plus square root of minus 27 divided by 2 can be written as 3 plus 3 square root of minus 3 divided by 2, and square root of minus 3 can be written as square root of 3 iota, since iota is equal to square root of minus 1. So 3 we can take common, and now we have 1 plus minus square root of 3 iota whole divided by 2. So one term we take positive and second term with the negative sign. So this whole is the value of no. So there is we want to write this in term of cube root of unity. So these values must be having negative sign. So we take a negative outside the bracket and one negative inside the bracket, so that we balance. So after taking the minus inside and outside the bracket, we have this form, and also we have taken the negative as inside and outside the this bracket. So now this whole term is equal to omega. This is with negative sign. So in negative sign we take the omega square, and the this is with positive sign. Here this is positive sign, so we take this as omega. So minus 3 omega and minus 3 omega square. So the 3 cube roots of minus 27 are minus 3 omega, and minus 3 omega square. So you have to remember that we take the positive value, this positive value with the omega, and the negative value with the omega square. Question 2. Evaluate part 1. Within bracket 1 minus omega square whole raised to power 7. So we have to simplify by using the properties of cube root of unity. And first the property we prove that the sum of the cube roots of unity is 0. So it means 1 plus omega square is equal to 0. So from here we can take minus as a common, so we can write 1 minus when we take minus common, so within bracket we have omega plus omega square whole raised to power 1, and we know that 1 plus omega square is equal to 0. So from the this equation we can write this as omega plus omega square is equal to minus 1. So replacing the value of omega plus omega square is equal to minus 1. So we have 1,
this minus and this minus, this will be positive 1, and so 1 plus 1 whole raised to power 7, 2 raised to power 7, which is 128. So you have to remember the properties of cube root of unity. The most important property is 1 plus omega square is equal to 0, and second is omega cube is equal to 1. So now part 2, 1 minus 3 omega minus 3 omega square. So here we can take a minus omega as minus 3 as a common. So, and omega plus omega square we can write is equal to minus 1. So this is minus 3 and this is minus 1. So when we multiply these two terms, we have plus 3. So 1 plus 3, 4, 4 is 4 raised to power 5, and this is equal to 1024. Part 3, now we can take 4 as a common. So by taking 4 as a common, we have omega plus omega square, and 1 omega plus omega square is equal to minus 1. So 9 plus 4 into minus 1. So this is equal to 9 minus 4. 9 minus 4 whole raised to power 3. So 5. 9 minus 4 is 5. So 5 cube is 125. So we are using the simple first the property 1 plus omega square is equal to 0. Now from here in first expression we can take 2 as a common. So we have 2 into 1 plus omega, and from here we can take 3 common. So from this 3 and from this 3, this is 3 omega square. So when we take the 3 common, we have 1 plus omega square, and this is minus 3 omega. So from the property 1 plus omega square is equal to 0. So we can take the value of 1 plus omega as a minus omega square, and 1 plus omega square will be equal to minus omega. So 1 plus omega will be minus omega square, and 1 plus omega square will be equal to minus omega. So after simplification, we can write this as minus 4 omega square, and this will be equal to minus 6 omega. So minus and minus 4 when multiply with this minus 6 and omega square, and this is omega. So this is plus 24 and this is omega cube, and we know that the omega cube is equal to 1. So this is equal to 24. Part 5. So from here we can see that if we divide this by 2 and here we divide by 2, this will be equal to omega, and this will be equal to omega square. So let's see. So it means we know that omega is equal to minus 1 plus square root of minus 3 divided by 2. So and omega square is equal to minus 1 minus square root of minus 3 divided by 2. So now if I multiply both sides with 2, then we have 2 omega is equal to minus 1 plus square root of minus 3, and here we have minus 2. Sorry. Here we have 2 omega square is equal to minus 1 minus square root of minus 3. So it means and this term can be written as 2 omega, and this can be written as 2 omega square. So 2 omega raised to power 6 and 2 omega square raised to power 6. So now 2 raised to power 2 is here, 2 is here. So when we take common from this, so 2 raised to power 6. So this will be equal to, when we take common, so 6, we have to take this power with 2. So 2 raised to power 6. So this will be equal to 2 omega raised to power 6, and this is 2 raised to power 6 omega raised to power common. Omega 6 can be written as omega cube square, and omega 12 be written as omega 3 raised to power 4. So omega cube is equal to 1 square, and here we have 1 raised to power 4, 2 raised to power 6 as it is. So we can take 2 raised to power 6 as a common. 1 square is 1, and here 1 raised to power 4 is also equal to 1. And 1 plus 1, 2, so 2 raised to power 6, and when we multiply with 2, we have 2 raised to power 6 plus 1, 7. And 2 raised to power 7 is equal to 128. Part 6, again you can see that we can write this as omega and this as a omega square. solution. So this is omega raised to power 9 and this is omega square raised to power 9. As omega is equal to minus 1 plus square root of minus 3 divided by 2 and omega square is equal to this value. So omega 9 and this is equal to omega 18. Omega 9 can be written as omega 3 raised to power 3 and omega 18 we can write as omega 3 raised to power 6. So omega cube is equal to 1. So we can write this 1 cube and this is 1 raised to power 6. 1 cube is equal to 1. 1 raised to power 6 also equal to 1. So 1 plus 1 is equal to 2. So this is the required answer. So part 7, omega raised to power 27 plus omega raised to power 38 minus 5. So we can write this omega raised to power 37 as omega and omega raised to power 36, and omega raised to power 38 can be written as omega 36 and omega square. Why we are writing this in form of 36 and here why separating this omega and this omega square, so that we can write this in the power of our in the exponent of omega cube. So 37 can be cannot be written as omega cube in a term of omega cube and omega 38. So we have to separate here omega and here omega square. So we can write this omega 36 as omega cube raised to power 12, and here also we can write omega 36 as omega 3 raised to power 12. So omega cube we know that is equal to 1. So 1 raised to power 12 and here is 1 raised to power also 12. So 1 into omega, this is omega, and 1 raised to power 12 is also 1, and we multiply with this omega square, we have omega square, and this minus 5 is just as it is we are writing. So now 1 plus omega square is equal to 0. So omega, from that we can write is omega plus omega square is equal to minus 1. So we can write this as a minus 1. So minus 1 minus 5 we have minus 6. Part 8. Again, we can write omega 13 as omega raised to power, this is minus 13. So omega raised to power minus 12 and minus 1, and here minus 17, we can write this as a minus 15 minus 2. So we can write here this is equal to minus omega raised to power minus 12. There is again minus mistake, sorry for this. So you have to write there is minus omega raised to power minus 12. Here we have omega raised to power minus 15 and this is omega raised to power minus 1. So I will write, and just you have to write here this is so this is minus, so this is minus 12. So we can write this as omega raised to power minus 1 can be written as omega cube raised to power minus 4. This is omega minus 1 as it is, and omega raised to power minus 15 can be written as a omega cube raised to power minus 1. So this omega cube is equal to my 1, and so we can write this as a 1. So 1 raised to power minus 4 here and 1 raised to power minus 5. So 1 raised to power minus 4 is also equal to 1, and 1 raised to power minus 5 is also 1. So we have minus omega plus omega raised to power minus 1 and omega raised to power minus 2. This can be written as 1 by omega. So, and this can be written as 1 by omega square. So 1 by omega, and we have a 1 by omega square. If I take omega cube as common, if we write this as omega cube as LCM, when we multiply this with, then we have omega square. So we have to multiply with this omega square. Now we can, when we divide with this one, we left omega, and we can write here omega. Here we can take omega square as a LCM, but why we are taking omega cube, so that we can write this in term of in the properties of cube root of unity. So that's why we are taking this in form of omega cube. So omega square plus omega can be written as -1, and omega cube we can write this as a 1. So -1 divided by 1, this is equal to -1. So this is important. Question number 3. X cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z times x plus omega y plus omega square z times x plus omega square y plus omega z. Solution. Now we have to take the right hand side to solve this. So first we multiply these two terms. So for this we have to multiply this x with this whole, then we take this omega y and we multiply with this whole term, and then we take omega square z and multiply with this whole term. So after multiplying we have x square plus omega square xy. So here is omega xz, here is omega xy, this is omega cube y square, here is omega square yz, and here we have omega square xz, omega 4, omega square and omega square, this will be equal to omega 4, and this is y, and this is y, this is z. So omega yz, and here is omega cube z square. So now we can uh, uh, we have to arrange these. First we write in from the value of xy. Just 1 minute, I take this pen. So here first we write the value of xy, then we write the value of xy, yz, and then we write the value of zx. So first write the value of xy. So here is omega x square xy, and here is this is again value, this is xy. So we write this here. Now x y, then we take the value of yz. So this is yz. So this is equal to omega square yz, and another value with yz. This is omega raised to power 4 yz, and just you take this as omega 4. How you can see that omega 4 can be written as, if I have omega 4, so I can write this as omega cube dot omega. So we know that this omega cube is equal to 1. So 1 dot omega. So this is equal to omega. So omega, we can see that omega omega cube is equal to 1. So omega raised to power 4 is equal to omega. So yz omega raised to power 4 can be written as a yz omega. So this is equal to yz omega. So we can write this as now another value with yz, and so now xz, there is xz, this is xz omega square xz here, and this is xz omega with xz. So this is values here, and omega cube we can write this thing. So this must be omega cube. Since omega cube is equal to 1, so we can take here 1 raised to power 3. Now from these terms we can take xy as a common. So we have a omega square plus omega xy, and here from these two terms we can take yz as a common, and from these two terms we can take xz as a common. So we left with omega square plus omega inside this. So as we know that 1 plus omega, this is the property of cube root of unity, that omega square, this is equal to 1. And when we take when we have to find the value of omega plus omega square, then we have to shift this sorry, this is equal to 0, sorry, this is equal to 0. So when we have to find the value of omega plus omega square, we have to shift this is equal to right hand side, so that we can write this as omega plus omega square is equal to minus 1. So that is, so omega square plus omega can be written as minus 1. Here we have to use minus 1, and here we have also use minus 1. So this is equal to x square, and this is minus xy, this is minus z, and this is minus zx. So here is, this is y square and this z square. By arranging, we have x square plus y square plus z square minus xy minus yz minus zx. So this is the formula for x cube plus y cube plus z cube minus 3xyz. So this is equal to left hand side. Part 4, question number 4. Prove that 1 plus omega times 1 plus omega square, 1 plus omega raised to power 4, 1 plus omega raised to power 8 up to so on, 2 n factors is equal to 1. The first step is that we have to write the values in terms of omega or omega square. So let's start the solution. Here omega 4 can be written as omega cube and omega 8 can be written as omega square and omega 6. So these remaining terms as it is. So this is omega square, omega cube, and this is omega cube. And now this is omega square, omega raised to power 6. So this can be written as omega cube square. Now we know that omega cube is equal to 1. So by replacing the value of omega cube is equal to 1, so we have, this is 1 plus omega, this is 1 plus omega again. This will be equal to 1 plus omega, and this will be omega square 2n factors. Now we know that 1 plus omega square is equal to 0. So 1 plus omega will be equal to minus omega square, and also 1 plus omega square will be equal to minus omega. So by replacing these values, so we have omega square, here we have a minus omega square, this is minus omega, this will be minus omega square, this is omega, up to so on to n terms. So if we combine these two terms, so it means all terms are in this form. First we have minus omega square, then we have minus omega, and then here we have minus omega, then we have minus this, here is minus omega square, and this is minus omega. Again we have minus omega square, and then we have minus omega. So if you combine two terms and write this in a one bracket, so it means this will be equal to, so when we take two terms as a 1, so this 2n factors will be equal to n factors. So minus omega and minus omega, this will be equal to plus omega cube, and this will be also equal to omega cube, and these will be n factors. And omega cube, we know that this is equal to 1, this is 1 n factors. It means 1 n times. We have to multiply 1 into n times. It means 1 raised to power n, and 1 raised to power n is equal to 1, which is the right hand side of the equation. So this is exercise